This is a Glastron aqualift boat with a 55 horsepower Johnson outboard. This was a freebie for good reason. Interior was shot. The windshield's missing. A lot of the hardware had been removed. I think somebody had planned on painting it and then gave up. The motor, when I got it, had a huge mouse nest in it. I actually spent quite a bit of time with the shop vac blowing and vacuuming out tons of debris. At some point somebody had done some kind of a rewiring job here and mounted these metal boxes up front here and did their own wiring. Don't know what these switches are supposed to do. Got a battery hooked up, can't make it turn over or anything. Then, upon closer inspection, pulled some of this wiring out, found the mice had gotten at it. Got a wire here that's completely chewed off. Several other wires that the insulation's missing. So I stripped off more of the electrical tape. And down here, you can see where the mice hadn't gotten to it, but where it's just plain, the wires are corroded and the insulation's trashed. So I'm going to work back to where I can find a good place to splice some new wires on and try and fix this wiring. Well, I just found a repair splice that was made right here that the wire pulled right out, and this looks like one of the heavy brown wires that might be associated with the solenoid. Right there, there's two brown wires going to the solenoid coil right there, so that might be part of why I'm not cranking over. Now, that wire that pulled out, this brown wire that went into here, that pulled out, just goes up to, looks like a temperature sensor on the head. Now, the more that I undo the tape here, the more scary stuff I see. Here's a wire here that was spliced and it's badly corroded. And then here's another wire here that the mice got to. So I'm just gonna continue to undo these strain reliefs and continue to undo all this tape. Alright, this plug here I unplugged goes down to this box right here. It's called the amplifier assembly. I guess this acts like a sort of exciter. And I guess it uses an impulse from, I think, a points under here. And then that amplifies it, amplifies the signal from the points and kicks up to drive this ignition coil right here. The ignition coil high tension lead goes back up underneath here to a distributor assembly, so that as this is spinning it decides which cylinder is going to fire at which point. I guess these can go bad, and when they go bad apparently they're no longer available, and it creates a whole another can of worms. I did find a link online to a site that shows how to convert this back over to a regular points ignition like the what the previous motors used. So anyways, I got that unplugged. Don't have to unplug this because that just goes to the ignition coil. Got this mess of wire and it comes up here. And unplug this plug here. It goes to this device right here, which I don't know what that is yet, but I will find out. Got this wire, this lone wire that runs up here. It looks like it goes to a switch. It's probably a cutout switch. Assuming that's what that is. And that's just one wire, so let's see if I can't figure out where that goes back to and disconnect it. Actually, I could just disconnect it from the switch. So that's on this right hand spade on the switch right here. If I can get in there with my screwdriver or pliers. A lot of these wires were either stuck together with like that, maybe they were trying to use that type of insulation, wire insulation that you just coating that you can paint on. Either that or these wires actually fried and melted together. I mean, this is just unbelievable. Every single one of these wires has all the insulation just breaking off and bare wire exposed and corroded wire inside of it. Alright, I keep backing down this tape and just finding that it's all the way down here. The insulation is deteriorated and the wire inside's all corroded, so the whole wiring is shot, as if that wasn't already evident. This wire right here that comes over to this plug, that's just a ground wire, so I'm going to disconnect that. And then this is kind of interesting. They got a wire here that goes to this grounding post. All it does is go down here to this screw, so I guess that just helps ground this bracket. Alright, more damage. Now that goes up behind there. It goes up to these cables, one of which runs over to a quick disconnect here. It goes to this device, and then the other one runs up here and goes to a quick disconnect here, one of which just goes to, well, actually one is a ground. This one goes up to underneath the flywheel. I wonder if that's your points. This one goes to a quick disconnect that goes to, this is probably your automatic choke assembly. Your electric choke is probably this device right here. So I'm going to disconnect this linkage right here. So I'm just going to pop this clip down, and that should allow me to pop this linkage off so I can maybe, where this cable connects, maybe I can get to this wiring a little better. Let's see. Yeah, that looks like that's how I'm going to get in there. Bend that right there out. I just can't get over how bad this wiring is. I mean, there's a whole corroded section with no insulation on it. This is hanging on by a strand. I mean, this is just unbelievable how bad this is. Oh, so now I've gotten these two separated. Got enough of the tape off to separate these two. And that shows me that this one goes down here and goes to a quick disconnect right there to disconnect it from this device. So let's see if I can't get that disconnected. And then I'm going to try and bend this clip out to see if I can't get these unplugged. Alright, whatever this is that's under the flywheel that this goes to, it comes down, it has two wires. One goes over to a grounding point right here, and the other one goes right here to this quick disconnect. And then you get this other quick disconnect goes over to the auto choke, and then you get that other one I still got to get to. It's buried in there. It goes to this device, which looks like some sort of a vacuum device, vacuum switch by the looks of it. Okay, you take this weird looking clip thing off, and then you can unplug this main connector right here, which separates the engine wiring harness from the wiring harness to the boat. So that's, once I get that separated, I did find out the two wires here, the two wires that go down to that solenoid. Interestingly enough, one of them is the wire that ran up to what that looks like almost like a cutout switch up there. So I'm assuming that what that does is that grounds one end of the coil, and then I'm assuming when the engine's running, what it does is it opens and inhibits the ability for the solenoid to accidentally be engaged while the motor is running. I don't know, just a theory. There's another good reason why it wouldn't crank at all. Here your main 12 volt feeds right here. These two wires right here. This one goes to this connector, which, let's see, this is a 2-prong connector. This must have went to, I don't even know anymore. Anyways, and then this other one is completely broken off, wherever it went to, probably right here. So this would feed the 12 volts through this plug back up to the switches up there. So you're not sending any 12 volts up there, you're certainly not going to get 12 volts back. Alright, so I'm going to cut these off because they're trashed and frayed and they're just dangerously exposed. I'm surprised I didn't get any fireworks when I hooked the battery up to this thing. But if I get these off of here, then I don't have to worry about them coming into contact with anything. Because what I'm going to do is I'm going to feed 12 volts directly to these two wires and see whether or not I can get this thing to crank over. Alright, so this wire that comes from the solenoid coil that goes directly to this plug, and just make my life easier, I'm just going to cut it and splice it right there. Well, not splice it, but cut it right there and bare the wire so I can get a connection. Alright, I got a temporary jumper wire hooked up. I'm feeding 12 volts to this right now, but the other end of the coil is not grounded, so that's why nothing's happening. But as soon as I ground this wire, that should energize the solenoid and it should crank over. Of course, obviously I'm not going to get ignition because my whole ignition system's wiring is completely disconnected and shot. But I just want to see if I can get this thing to crank. I'm getting a little bit of a spark when I put this on, which makes me think that I've got a coil that's drawing current, but it's not energizing. Alright, let me do some resistance checks on that coil. Now, so what I've probably got is I've probably got a solenoid that's frozen. In other words, the coil on the solenoid's not open, but what's happening is the inside of that solenoid, if you look right here under the cap, you can see a lot of corrosion right there. It's probably frozen, so that actual piece that's supposed to slide up and down is not moving. So add starter solenoid to the list of things that are clearly wrong with this right off the bat before I do anything. Well, even getting this solenoid coil out is being a bear. This screw is seized in there and I can't really get a good grip on it. I'm sure if I put a little bit of penetrating oil or some heat or a combination of both to it, I'll be able to get it out. But quite frankly, not really that motivated to work on this thing. It's just got more wrong with it than I want to deal with right now. You know, if this was the fall, I had acquired this and I started working on it then, and I worked on it through the winter and didn't have any other projects going, I probably would do something with it. But I will, just for giggles, see if I can put my jumper cables right directly to the starter and see if we can't get the starter to spin up. Because at least, I mean, I know it's not seized because I was able to rotate the thing, the flywheel by hand. Let's see, it was a good ground point. I guess maybe right here. Not even sure. Let's try grounding it there and see what happens. There we go. Oh, my battery's low? Didn't think it was. I could turn this by hand. That should turn a lot easier than that. Is that starter not good? I'll have to get my starter charger on here and see. Couldn't resist the temptation to mess around with this outboard just a little bit more before I throw in the towel. I had a solenoid starter, a generic one, I mean, I bought this thing over 10 years ago, I think. Well, it says here, date 5 of 96. Paid $7.99 a cap of the good old days. Anyways, I think that'll be a good enough replacement for this one that's in here. So I'm going to swap the solenoid out. At least then I should be able to get the thing to crank over decent with a good battery charge and some good cable connections. But I've got to get this old solenoid off of this bracket here, so I've got to get that frozen screw out. So I'm going to use the torch and put some heat to it. Heat it with the torch, then give it a few taps with the hammer, and it comes right out. So now, hopefully this is a separate. Yeah, it's just because I don't want to have to deal with getting the screw on the underside out, because that would mean taking this whole deal off here, I think. I guess I could have gotten the screwdriver in there, but I'll just bend this bracket. Okay, that makes this getting this out easy enough. Just bend the bracket down and pull this whole assembly out. On some of these, there's 4 screws. You can take this cover off and you can actually service the inside of this. You can pull the plunger out, clean it up, and if the coil's still good, like this one, you can actually make it work again. This one is riveted, so it's not worth dealing with. So I'm going to take the cables off. Alright, I'm going to have to modify this new one because this one has an integral bracket. And the problem is that I could probably use this bracket if I was willing to take off the old bracket, this old strap. A couple of problems with that. First being, I like how this has actually got this rubber strap that goes around it that helps isolate vibration. The other thing is that I'm going to have a heck of a time getting that bottom screw in, even if the screw holes do line up. So what I'm going to do is I'm going to cut this bracket off. Gonna cut this off with a hacksaw in a way so that I can minimize the amount of stress I put on this end point right here. Some careful cutting with a hacksaw. I was able to get the bracket off without damaging the solenoid case. Not just for my testing purposes, I've hooked up a different positive cable because I don't have a good battery. That's the original battery. This was the boat. It's junk that has those type of connections on the top. I've just got the regular post here, so I've got to make a connection somehow. And then to handle a negative side, I'm just doubling up my jumper cables and running that back to the ground there. Hopefully that'll be a good enough connection. And then it appears one side of this coil gets grounded through a switch up here. And then the other side of the coil, if that side's grounded, then this side of the coil would need 12 volts going to it to actually fire the coil. So that being said, I should be able to ground one side of this coil and touch a screwdriver from here to here, and it should energize. And depending on how this coil is wired, I might not even need that. No, it does. Okay. Sometimes they're 3-wire coils. You've only got one post on those because it's internal, where one of these posts is connected to the other to another post that isn't there. Does that make sense? No. Now I've temporarily remade the wiring that goes from here up to that switch, and you may notice that right off the bat I'm using the wrong wire. This is only 20 gauge wire, and the reason why I'm using such a light wire is because I don't have any 90-degree connectors like that, spade connectors that are at 90-degree angles. I have straight ones. If I put a straight one on here, the wire is going to come out this way. I'm going to have to twist it around. It's going to interfere with the linkage here, so I don't want to do that. So I had this piece of wire that had one of these at each end, so I cut that, but it's only 20 gauge. And then when I get down this end, if I put a crimp connector on there for 20 gauge, the hole's too small, so I've got an oversized crimp connector. So this is just all wrong. But I want to stress, I'm only doing this to test this thing out and play around with it a little bit. I would never leave it like this and take it out on the water this way. If I actually got this thing running and wanted to actually test drive it, I would go through the extra effort of going back and remaking this wiring with the proper gauge wire and the proper connectors. Wow, just when I thought I seen everything. when I touch this to here, I should get the solenoid to close because I'm sending 12 volts to this side of the coil, and this side of the coil is grounded by the switch. Nothing happens. First thought was, switch isn't grounding. Check continuity from the switch to ground, it's okay. So my second thought was I had a bad connection because I was just jumping with the screwdriver. So I actually got a connector on there. Nice clean connection right there. Nothing. Only one thing left to do. Check the continuity of the coil in the new solenoid. Open. So how do you like that? Brand new, out of the box, open solenoid coil. And I certainly can't return it under warranty since I bought it in 1996. I was thinking about that brand new coil being bad last night, and then it occurred to me, I remembered I had that same model coil solenoid before that I used in my old boat that sunk. And I remember when I first replaced it, I thought the same thing. I had the same problem. It wasn't working. And then what I figured out was it's wired differently. It actually uses the bracket as the ground, and one of those two posts doesn't appear to do anything. So I cut the bracket off. So what I did was I just soldered the wire on to where the bracket used to be. And now when I pulled it across my battery posts, I already tried it. I just held this wire on, held one post on to one terminal and hit it, and it clicks. So now I got a solenoid that works. And what I did was I put this in there, soldered it so that this is going to face up when it's mounted in there. And that way this wire can now go up to my switch up here. And I got the wrong kind of connector on the end of it. I got that straight one and I wanted a 90 degree, but oh well. Figured if I was going to go through the trouble of soldering a wire on, I wanted to solder one with the proper gauge on, not the really thin one that I was using yesterday. About ready to give this motor a test spin and decided to pull the plugs before I did and see what they look like. That one's not horrible. That one's got a little bit of rust on it. And that one's got a lot of rust on it. So I'm going to spray a little something inside the cylinders before I spin it. Alright, let's check it out. Alright, so I'm going to get my compression gauge and see what the compression looks like. Well, top cylinder is 105. The middle cylinder is just a hair below that. Looks like it's about 102. And they're all measuring about 105. So all three cylinders seem to have pretty good compression. So now the question is, can I get spark to this thing? Can I Mickey Mouse wire this thing just enough to get some spark to it? Because if I can get spark to it, and I've got compression, I might actually be able to get this thing to run. And if I can get it to run, even half decent, then it might be worth me investing in the new wiring harness. Oh, the wiring harness is obsolete, by the way, but I did find some harnesses on eBay that were similar to this one. They at least have the correct plug on it. So what I could do is I could get those in, plug it onto here, and then rewire and splice in what I need to make it work. But I don't even want to buy one of those because they want about 30 bucks for one of those, used ones. So I'm not going to bother doing that unless I see whether or not I can get some spark out of this thing. So next step is to get a wiring diagram. Hopefully I can snag one from somebody up online. Here's the data plate. This is a model 55. E is in Echo, S is in Sierra, L is in Lima, 69A.